What does the mass loss look in Antarctica right now? This is the same scale as for Greenland. Going back to the 70s, you see this increase in mass loss, and here it's not even linear. I mean, it drops down very quickly because of the Pine Island area. It's almost an exponential decrease, and these are the GRACE data. The acceleration is a little bit less than Greenland, but it's catching up. The mass loss in 2007, just as large as Greenland. That's big news. You don't find that in the last IPCC report. The last IPCC report still says, well, we're not sure about Antarctica because they didn't believe Isabella. But they should believe Isabella. What's important to keep in mind, though, this is only 10% of the annual input in Antarctica. I told you for Greenland, it's 100%. For Antarctica, it's only 10% of out of balance. So that shows you the potential of mass loss from the Antarctic. It's leaking a little bit right now, but it could do a lot more than what it's doing right now. Why do they do this? Why do they do this to us? Meltwater. It's the meltwater. The Kool-Aid recipe, that's how I call it. You know, you put meltwater on the glacier, it's going to get down to the bed, it's going to lubricate the bed, it's going to flow faster. So everybody rushed to the ice sheet to measure the meltwater and measure the meltwater going down to the glacier. Well, and it flows down these big holes. You know, big holes here. This is a little guy here, this is a big river, and it goes down the hole, down to the bottom, a kilometer down. No way back, no elevator to come back from that. However, if you look at the change in speed of a glacier in Greenland throughout the year, if you compare the speed in winter, it's dark, cold, and you compare that in summer, where there's so much meltwater you have to use boots to walk around or scuba diving equipment, the change in speed, 10%. The observed speed up of this glacier, 100, 250%. So melting is not a big factor. Yeah, it's losing mass. The ice sheet is losing mass, but that's not what's causing these glaciers to speed up. How about the ocean? In 1907, this is a time series of ocean temperatures from fisheries, people looking for shrimps. They realize now that they're working for us, looking at climate change. They didn't expect that. But you see the blue, that's the cold water, and suddenly it becomes all warm everywhere along this is the coast of Greenland, and it stays warm throughout the whole period. How warm? 3 degrees warmer. That's huge for the ocean to be 3 degrees warmer. Jakobshavn collapsed just a few years after this started. It thinned 80 meters per year during that time period. When my colleagues published that number, I thought, 80 meters per year? How can you get that? How can we get 80 meters thinning per year on a floating ice shelf? I had no idea. And at the same time, on the other side of Greenland, these glaciers also collapsed, and they were also bathing into these warmer waters. So the ocean did it. Well, the problem is not a lot of measurements of the melting of these glaciers into the ocean. Not a lot, because glaciologists don't look at the ocean, and the oceanographers, they don't cruise in the Greenland waters, they cruise in the tropics. They're smart people. So we sent a special team from UC with our own funding, with UC funding. Instead of sending a proposal and hope that within the next 3 years we're going to get funding and do the work, we said, let's go. So we had Slavek from UC Santa Cruz, Michel Copes from Canada, that's me. There's a local pilot, Isabella. Santa Claus came to bless the expedition. And a student who was not sure he was going to study ice or do something else. So we did some measurements. We measured the temperature and salinity of the water. We had, and this is a current meter. This is to measure the salinity and temperature, and these are the measurements. And this is the speed. And what did we find? We found on these 2 glaciers over here, melt rates of 2.4 meters per day. Per day. On this other glacier over here, Kudjat Lake and Avangard Lake, 4 meters per day. These rates are 100 times bigger than the melting at the surface, 100 times bigger. And the melting of these calving faces is so large, it almost equals the input of ice from upstream. So the ice comes into the ocean and almost melts continuously from the ocean boundary. Yeah, it produces icebergs, but it's melting continuously from the ocean. So submarine melting, it's not a little cocktail to entertain the parties, right? It's the main factor controlling the evolution of these glaciers. And it's direct, it's instantaneous, right? You warm up the ocean, the ice is going to melt faster.